First off, to avoid confusion, yes, we pretty much only use the TCP IP model, but the TCP IP model is basically like the OSI model, just with a few less layers. So in order to just get a hang of it all, I'm explaining the OSI model, but we use the TCP IP on a day-to-day basis. The OSI model is easily put the thing that allows devices to communicate with each other all across the world in a safe and reliable manner. But not only devices of the same type, but the OSI model allows all different types of devices to actually communicate with each other. The OSI model is simply put just a bunch of rules for how packages we send over the internet should be handled in order to communicate with other computers. The OSI model can be divided in 7 different layers that do different things in order to transport the data from one computer to another. Whenever we send a package over the internet, the package goes from the 7th layer to the 1st layer, and all layers add specific information to the package when it passes their layer. The 7th layer, or the application layer. The application layer is more or less the way that we actually submit the data we want to send over the internet, such as a website where we press buttons in order to send data to a web server hosting the data we want to access. Number 6. The presentation layer. The data that the user has put into the application layer gets taken here, where the presentation layer changes and encrypts the data to the specific format that the network the package is being sent to needs to have. As an example, it can convert some text into ASCII format if the networks need it to be in that way. Number 5. The session layer. The session layer establishes a connection between the computers so that you safely can send the package you want to send without the risk of losing the package. The session layer also keeps track of whenever a package is lost. 4. The transport layer. The transport layer helps to actually send the message. Whenever the presentation layer notices an error with a package, the transport layer is able to send that specific package back to the other computer. The transport layer also breaks down the package into smaller packages and gives them all headers. We also need to quickly cover the difference between TCP and UDP, who both work on this layer. The TCP protocol is slower but more reliable, as it more or less asks the receiver if they receive every package and then sends the package back if the receiver didn't. UDP is much faster, but it is also less reliable, as it doesn't check if you got the package or not and just keeps sending. As an example, YouTube uses UDP since otherwise the video will just hop back and forth if you ever miss the package. The transport layer also keeps track of the port that the package is being sent to. 3. The network layer. The network layer keeps track of the IP address that the package is being sent to, which basically is the destination that the package have if they were to travel over the internet. It also calculates which route that the packages are taking over the internet between different data centers to get to the destination in the most reliable and fast way. 2. The data link layer. When a package arrives at your router, it needs to know which computer on the local area network is going to specifically. This is when the so-called R protocol is in place. Switches that connect all computers and routers on a local area network only deal with MAC addresses. They can't understand IP addresses, and thus they send a question to every computer on the network asking which computer it is that owns that specific IP address in the package. The computer that then owns the IP and then sends its MAC back, and the MAC address is stored in the other computer during a small time, or in their so-called cache memory, so as to prevent having to use the R protocol over and over again. Number 1. The physical layer. This is where the messages actually are being sent in the form of bits consisting of zeros and ones. The physical layer consists of signal towers, long cables, and other things transporting the actual signal. If you found this video helpful, subscribe on coming home to you and hiding under your bed.